Hi guys, and welcome to our last new video of this chapter. Now our test is not until the end of next week. So the next time I see you in person, we will be taking a quiz. And then it's about a week and a half to catch up if you've fallen behind, to work on your Delta math, and to practice, practice, practice. In today's final video, we will be taking a look again at our radical equations, but as we learned last week, a radical can also be written as a fractional exponent. So today, we're specifically going to look at equations with fractional exponents. Let's get started. So here's my first equation. It is 2 times the quantity, x plus 3. And then this 2/3, that's an exponent on the parentheses, and then it's equal to 8. Now, because the parentheses has an exponent, we are not allowed to distribute the number 2 into the parentheses. Instead, what we're going to do is we're going to take that 2 that is not trapped inside the parentheses, we're going to move it to the other side. So I'm going to divide by 2. It was being multiplied. I'm going to divide. Now, I need that exponent to get off of those parentheses, right? Everything is trapped inside the parentheses until the exponent goes away. To get rid of an exponent, you're going to multiply the exponent by its reciprocal. So we have 2/3. I'm going to flip it, and I'm going to make it a 3/2. And whatever we do to one side, we have to do to the other side. So if I'm going to put an exponent of 3/2 on the left-hand side, I also have to put an exponent of 3/2 on the right-hand side. Now, the good thing for us is on the left-hand side, those fractions are going to cancel out. So now we're just going to be left with the parentheses, and we actually don't even need the parentheses anymore. We can just write x plus 3. On the right-hand side, we do want to evaluate this. This is what we were learning last week. 4 to the power of 3/2 means take the square root of 4 and raise that to the 3rd power. Now, as we've learned, oh my goodness, in previous, first semester chapters, if we are in the process of solving an equation and we decide, it's not in the original problem, we decide to take a square root, which is what we're doing right now. I'm going to take the square root of 4. Then we have to put a plus or minus sign in front of it. So be on the lookout. And this is actually not just for square roots, it's for any index that's even. So square roots, 4th roots, 6th roots, 8th roots, any even index. Now you don't have to do this with an odd index because an odd index will actually tell you if it wants the answer to be positive or negative, depending on what sign the inside number is. So you only need plus or minus for even index. The square root of 4 is 2, and 2 to the 3rd is 8. And we're almost there. So I'm going to subtract the 3. I'm going to put the -3 in front of the plus or minus sign because that's the most natural, least confusing place to put it. And then we do get 2 answers. So -3 plus 8 is 5, and -3 minus 8 is -11. Okay, so 2 answers for this problem because we ended up taking a square root. Now, in yesterday's video, we learned that it's important to check our answers when we're doing a radical equation. And this equation technically was a radical because it had a fractional exponent, and that's what fractional exponents do. So let's check and see if one, both, neither of those are actually answers. Here I am checking the number 5. You'll need to get the inside of the parentheses down to a single number. Here, the next thing I'm going to do is my exponents. So if you think back to PEMDAS, PEMDAS says parentheses, exponents, then multiply. So do not multiply the 2 times the 8. Figure out what 8 to the 2/3 is. And that means cube root the 8 and then square that. And now I can multiply these together. 2 times 4 is 8. So 5 is an answer. Let's check our other answer. Our other answer was negative 11. So negative 11 plus 3 is negative 8. Just like in the first one, I'm going to cube root the negative 8. Now you are allowed to cube root a negative. If you have an odd index and the inside number is negative, you're just going to get a negative answer. So I get negative 2. Negative 2 squared will change into a positive 4. And that one also worked. So both of these answers worked. My two answers to this problem are 5 and negative 11. Let's try one more, and then we'll be done with our notes for this chapter. In this problem, again, I have my parentheses, and everything with the parentheses is trapped right now, but anything that's on the outside can be moved. If I have the choice between moving a multiplication problem, and this 3 is being multiplied with the parentheses, or moving an adding problem, the plus 1 out here is being added, I'm always going to move my adding and subtracting first. So I'm going to take the outside plus 1, not the inside 1, and I'm going to minus it to the other side. Next, I'll take this front number 3 that's technically being multiplied, and I will divide it to the other side. Once your parentheses are completely alone, then you can take the reciprocal of your exponent, and you have to do it once on each side. So make sure it's a 5 over 3 on both sides. On the side that had the original exponent, those will cancel. It's very nice. And then on the other side, we got to figure out what that turns into. So 8 to the power of 5 over 3, that means take the cube root of 8 and raise that to the 5th power. Now, in this one, I have an odd index, so I don't need my plus or minus sign. Odd indexes do not need a plus or minus. The cube root of 8 is 2, and 2 to the 5th is 32. And then for my last step, I'm going to minus 1, and I think my answer is 31. Now, again, we can plug that back into the original question to check and make sure that it works. I'm going to start, this is now PEMDAS, I'm going to start inside my parentheses. 31 plus 1 is 32. And then this exponent says to take the 5th root of 32 and then raise that to the 3rd power. So the 5th root of 32 is 2, and 2 to the 3rd is 8. 8 times 3 is 24, and 24 plus 1 is 25. So we did good. This concludes our Chapter 6 notes.